We are now on lesson 3 of chapter 4, which is similar figures. First, we're going to identify similar figures. Then we're going to find missing measures in similar figures. And then we'll do a real-world application. Just a reminder that similar figures have the same angle measurements. And here this 90 degrees matches up with that 90 degrees. This 90 and that 90, that 90, that 90. So the measures need to be the same so that this one passes that first test. And then the second one, they have to have proportional sides. And since these are proportional, we can determine the lengths of unknown sides by using proportionality. So here I see the short side of this bigger rectangle is 2, and the short side of this smaller rectangle is 1. So I see that this is twice as long as this. So therefore, this x is going to be twice as long as this long side, which is 2. Twice of 2 is 4. So I could replace this x with a 4, because this is twice as long as that. Let's use that for this triangle then. First we need to identify similar figures. So which of these triangles are similar? Remember, they need to have similar angles and then proportionate side lengths. So first we have this triangle A, 33, 65, and 82. Well, first thing I notice that this 33 does not match up with this 33 degrees. But it does match up with this. Same thing with the 65 down here. Does not match up with the 70, but the 65 over here it does. 82 and 82. So the similar angles would be A and C. So since proportional figures have to have the same angles and proportional sides, I know that A and B cannot be proportional. But A and C right now are on the right track. Let's check out proportionate side lengths here. To test for that, I could find the longest side of this triangle over here and compare it to the longest side of this triangle. Here I see that this is 26 for the longest side. The longest one over here is 13. So I see that's a 2-to-1 ratio. Let's see if the other sides follow that same rate. The second longest is 16. Well, the second longest over here is 8. So 16 over 8. And just like that first one, it's a 2-to-1 ratio. So it looks like they are proportional so far. Let's just do the last one just to be sure. This one's 14 and this one's 7. So 14 over 7, and it looks like these are all proportional. This one's an easier one because I see that they're all twice as much. If sometimes it's a little more difficult than that, so we can do cross products. Let's just do that for this one, for example. Is 16 times 7 the same as 14 times 8? So 16 times 7 is 112. 14 times 8 is 112. And then you can do it for this one if you would like as well. 16 and 13. 26 and 8. So 13, 16 is 208. 26 times 8 is 208. So it looks like we're all set. It's really important though, if you do that, to make sure you have all the big triangle ones on the top. All these ones from the top need to be from that triangle. All the ones from the bottom need to be from that triangle. You can have all these on the top or bottom as long as they're all together. That's the most important thing. These numbers need to be all together because they're from the same triangle, just as these numbers need to be all together because they're from the same triangle as well. Let's find missing measurements then in similar figures. A picture is 10 inches wide and 8 inches tall. And I'm a visual guy, so I'm going to draw a picture like this. So I know it's 10 inches wide and it's 8 inches tall. To display the picture on a web page, the picture must be reduced to 3.5 inches tall. So if we're going to make it just a smaller one just to help us out a little bit. I know that this was 8 inches tall, so we're going to make this 3.5 inches tall. How wide should the picture be on the web page for the two pictures to be similar? So we need to find the width of this new figure here, with which we can make an X, or W for width I'm going to go with. So we have 8 by 10 is proportional to 3.5 and what? We can make a proportion here. We have 3.5 and 8. 3.5 is the length, and so is the length over here. So we can go with 3.5 over 8. So I notice I put the smaller figure on top and the bigger one on the bottom. That's fine. I could have gone 8 over 3.5, but since I did 3.5 on the top, now I need to put W on the top because that's also on the same shape. And on the bottom, I'm going to put the 10 because the W matches up with the 10. So W over 10. And then I could solve for W by using the cross products method we learned last lesson. W times 8, or 8W, equals 10 times 3.5. 10 times 3.5 is 35, so 8W equals 35. Divide both sides by 8. And we have 35 divided by 8. And that's 4.375. So W would equal 4.375. So that's how wide this picture is. And then let's not forget that this is measured in inches, so it would be 4.375 inches. Finally, a real-world application. So a souvenir model, so the smaller model of the pyramid over the entrance of the Louvre in Paris, has faces in the shape of a triangle. The two sides are each 4 inches long, and the base is 5.1 inches long. So if we're going to mark this triangle, the base would be 5.1, and the sides would be 4. On the actual pyramid, each triangular face has 2 sides that are each 27.8 meters long. So the similar sides are 27.8. So here we had 2 4s, so this is where the 27.8 would go on the actual pyramid. 27.8 meters then. So how many meters is the base going to be? I'm going to do B for base. So we can create a proportion here to solve this. And I know that this correlates to this, or this is in relationship to this if they're similar. So the 27.8 from the big one, 4 from the small one. So if I make a proportion, it'd be 27.8 over 4. I don't need to do that again for this because these are exactly the same ratio. I can just measure with this one. But now we need to find the base and the 5.1 inches. Since I did the 27.8 from this triangle on top, I need to put the B for base on top. And that will be over the 5.1 inch base over here. So here's my ratio. 27.8 over 4 is equal to B over 5.1. So what I can do is I can cross multiply. So I have 27.8 times 5.1 equals B times 4. I'm going to write that algebraically. It'll be 4B equals 27.8 times 5.1. 27.8 times 5.1 equals 141.78. So 4B equals 141.78. Then I could divide both sides by 4. So 141.78 divided by 4 is 35.445. So B equals 35.445. And then that would be in meters. So my answer would be 35.445 meters.